That's the case in general. If you have n inputs and k outputs, you have n plus 1 times k parameters to use, not one more. The thing is, you might want to use many, many more parameters in practice. Also, it's linear. This means that the kind of interactions that you're capable of representing with that model is somewhat limited. For example, if two inputs interact in an additive way, your model can represent them well as a matrix multiply. But if two inputs interact in a way that the outcome depends on the product of the two, for example, you won't be able to model that efficiently with a linear model. Linear operations are really nice, though. Big matrix multiplies are exactly what GPUs were designed for. They're relatively cheap and very, very fast. Numerically, linear operations are very stable. You can show mathematically that small changes in the input can never yield big changes in the output. The derivatives are very nice too. The derivative of a linear function is constant. You can't get more stable numerically than a constant. So we would like to keep our parameters inside big linear functions, but we would also want the entire model to be nonlinear. We can't just keep multiplying our inputs by linear functions, because that's just equivalent to one big linear function. So we're going to have to introduce nonlinearities.